So we're going to have a look at the answers to these speed calculations using Wildap. It's really, really important you lay out your calculations in this format. So the first thing we're going to end up writing down here, W, means write out the equation. So we're being asked to calculate the speed. So the equation we're going to write is speed is equal to distance over time. And so then we look at I. I means insert numbers. So speed is equal to the distance, which is 1200 meters. We'll go over the question there. And then the time is 320 seconds, which we pulled over the question there. In this case, we don't need to rearrange anything, so we can leave that blank. Evaluate it. We might reach for our calculators if we need them, and we'll find that speed is equal to 3.75. That's what comes out of our calculators. The S means significant figures. So we have a look at the numbers we've got up here, and that could be to 4 sig fig, could be to 3, could be to 2, we're not really sure, doesn't tell us. This one could be to 3 sig fig, or it could be to 2 sig fig. So we're looking for the smallest number of significant figures. So that'll be 3.75. We're looking for 3.75. That is to 3 sig fig. U is the unit. We divided our distance in meters by time in seconds, so our unit is going to be meters per second. P, is it plausible? Is it possible that you covered 3.75 meters per second? I think that would probably be a pretty quick walk, probably bordering on running, really, that is, but it's plausible. So we're happy with that. Let's have a look at question 2 then. If we have a look at question 2, we're again asked to find the speed of the snail. So we're going to write the equation down. Speed is equal to distance over time. If you didn't lay out your calculation correctly for question 1, maybe now's a good time to pause the video and go back to your working out for the remaining questions, 2 onwards, and do the working out properly. So back to our snail question. We're going to take the distance. Well, the distance is 54 millimeters. So I'm going to write 54 in there. And then I'm going to divide by the time, which is 480 seconds. Again, we don't need to do any rearranging, so we're not too concerned by that. Evaluation, we're going to do 54 divided by 480, which my calculator tells me that that is 0.1125. So S, significant figures. This was to 2 sig figs. This is either to 2 or to 3 sig fig. So the smallest number is 2 sig figs. We should have a number to 2 significant figures. So I'd be expecting that to be rounded to 2 sig figs. So that's 0.11. We're looking for a unit. Well, we divided a distance in millimeters this time by a time in seconds. So the unit is going to be millimeters per second. And that's fine. And is that plausible for a snail, 0.11 millimeters per second? Yeah, I think that is. If you chose to do the conversion to meters, then this line here would have read 0.054. What you've done is you've divided 54 by 1,000. There's 1,000 millimeters in a meter. So you would have that calculation to evaluate, and your final answer would end up as 0.00011 meters per second, and that's perfectly fine as well. Let's have a look at number 3 then. So we're being asked to find a speed again. So we're going to end up with speed is equal to distance over time. We are going to insert the numbers. So we have 4,200 over 150. We don't need to do any rearranging. We're going to calculate that as a speed is equal to 28. Significant figures, well, that was to 2, 3 or 4 sig fig, we're not sure. That was to 2 or 3 sig fig. So we're happy with an answer that maybe is to 3 sig fig. So 28 is fine. You might even write 28.0. That is actually 3 sig fig. The units, well, we divided the distance in meters by time in seconds. So that's going to give us a unit of meters per second. Is that plausible? Is it plausible for a car to go 28 meters per second? Yes, it probably is. So we'll stop this little video here and give you the chance to catch up on that, and then we'll have a look at the remaining questions in